In the previous video, we discussed the basic concepts of electrolysis, where we define the electrolysis and define the basic concepts and explain them. Now, in this video, we are continuing from where we left off there. We are going into the mechanism of electrolysis. The mechanism of electrolysis is based on the modern Ionic theory, of course, which is an improvement of Arrhenius' Ionic theory. The modern Ionic theory states that an electrolyte exists in the form of ions in molten states and hydrated ion in aqueous solution. And of course, we know that an ion is an atom or a group of atoms which carries a. We saw in the previous video that sodium chloride is a typical electrolyte. So let's consider the dissolution of sodium chloride in water. This is shown on the board. We have it as sodium chloride dissolved in water. We have sodium ion and chloride ion. This is hydrated sodium ion and then hydrated chloride ion. I placed this water here to show that it is dissolved in water. They did not essentially react. So this is an example of electrolytes. And this is essentially what happens in every electrolytic process. There must be ionization. Any substance that cannot ionize is not a good electrolyte, cannot serve as an electrolyte. That explains why sugar, that is common sugar, glucose, sucrose, and so on, they cannot serve as electrolytes, whereas sodium chloride is a good electrolyte. So next, I'm going to show you a diagram of an electrolytic cell. An electrolytic cell is an assemblage of electrodes. We've defined electrode before, of electrodes in an electrolyte, and they are connected to an external source of direct current. The diagram is shown next. This is the electrolytic cell. You can see the two electrodes, the anode and the cathode. The anode is positively charged and the cathode is the negative electrode. You can as well see the anions and the cations. Anions are the negative ions and cations are the positive ions. As well, you see the electrolytes. And now you also see the external circuits, external direct current circuit to which everything is connected. Let's now consider the mechanism of electrolysis of sodium chloride. Let's check here on the board. We see sodium chloride when it is molten, this is solid state. On melting it, you have sodium ion and chloride ion. So it follows that sodium ion would migrate to the cathode, being the positively charged ion, and will get discharged there. And chloride ion will migrate to the anode, being the negatively charged ion, and will get discharged there. Now we have this second scenario, sodium chloride in aqueous solution. Now it will ionize this way. When you complete the circuit, you have the two cations, hydrogen ion from water and sodium ion from sodium chloride. You now have the two anions, chloride ion from sodium chloride and hydroxide ion from water. Now we have a consideration now, because only one cation would get discharged and only one anion would get discharged. We know that in this one, we know that sodium ion will get discharged and chloride ion will get discharged. But this second scenario, we have a challenge. How do we determine the ion that will get discharged? We are going to consider this under preferential discharge of ion in our next video. But for now, let us see how sodium ion would get discharged and how chloride ion would get. We have sodium ion. Each will accept an electron. Each sodium ion will accept an electron. to get discharged as sodium metal. Each chloride ion would lose an electron to get discharged as chlorine atom. So because chlorine cannot exist as an atom, we have to write it as chlorine molecule here. Now, the details on this we've discussed in a previous video under redox reactions. So this is the summation, and this is the mechanism of electrolysis of molten sodium chloride. In our next video, we shall be focusing on aqueous salts, and we shall be considering the principle of preferential discharge. Thank you very much.